We're going to take another look at the law of sines. You'll remember that the law of sines is the sine of A over side A, and that is equal to the sine of angle B over side B, which is equal to the sine of C over side C. This formula is a lot simpler to deal with than the law of cosines. However, there's a little more to the law of sines that you have to consider, and that's what we're going to talk about today. So here we have triangle ABC, and I'm given that side C is 10 centimeters, side A is 6 centimeters, and angle A is 30 degrees, and I want to find angle C. I have a diagram to illustrate this situation down here. I have angle A here, that's 30 degrees. I have side C, 10 centimeters, and here's side C. I don't know side B, that's here. I'm going to draw a ray to illustrate that situation for side B because I don't know the length of it. And then I know that side A over here is 6 centimeters. If I draw an arc around side B that is 6 centimeters, well, has a radius of 6 centimeters, you'll notice that the arc intercepts this line here in two spots. I don't know which one of these is my triangle. Let's try calculating first angle C and see what happens. Alright, so I'm going to use sine of C over side C is equal to sine of A over side A, because side A and angle A are the only full ratio I have. Alright, so the sine of 30, I'm filling in the values I know, over 6 is equal to the sine of C over 10. And continuing with that, that means that the sine of C equals 10 times the sine of 30 degrees divided by 6. And then C equals arcsine of 10 sine of 30 divided by 6. Again, you should be in degrees because we are working on triangle trigonometry. When I plug that into my trusty calculator, I get that C is equal to 56.44 degrees. Now, if it's true that I possibly have two values of a triangle for angle C, we're going to call this 56.44 degrees. How would I find the other value? Well, if I look at the unit circle and I draw roughly a 56-degree angle here, sine is the y value of my triangle, and it's positive in quadrant 1. Your calculator always defaults to quadrant 1. If I wanted to find the other possible angle, I'm going to need to use reference angles. So sine is positive in quadrant 2. So here I would have the same reference angle of 56.44 degrees. So in order to find this value, I'm going to need to, well, actually I'm looking for this one, this angle here. I'm going to need to subtract this reference angle here from 180 degrees. So it's 180 degrees minus 56.44, and that's going to give me my second possible angle. And that gives me an angle of 123.5 1.56 degrees. So there are two possible triangles, and if you look at the diagram, you can see that that possible angle would fit here. So there are two possible triangles in this scenario. So here I have another triangle. Here's the second scenario that could happen. I have, again, side C is 10 centimeters, angle A is 30 degrees, and I have a diagram for that. This time, side A is 5 centimeters. And so again, I don't know the length of side B, so I'm drawing a ray to illustrate that situation. And from point B, I have an arc with a radius of 5 centimeters drawn. And you can see that side A intersects side B in one spot. If I try to calculate that, I have sine of C over side C equals sine of A over side A. And then I'm going to fill in the values I know. I don't know sine of C, and that's what I'm looking for. I know that C is 10 centimeters, and I know that's equal to the sine of 30 over 5. Which means that the sine of C equals 10 times the sine of 30 over 5. So the sine of C equals 1. Ooh, does that look familiar to anyone? And C equals arcsine of 1. And if you remember your unit circle, you'll remember that C equals 90 degrees. Because on the unit circle, the sine is only 1 at 90 degrees. So if I draw a picture to illustrate that, sine is the y value, and I look for another place on the unit circle where sine is 1, there isn't one. So the conclusion that I can draw is there's only one possible triangle in this scenario. But wait, there's more. Here, I have another situation. I have triangle ABC. Again, angle A is 30 degrees. Side C is 10 centimeters. This time, side A is 3 centimeters. Here's side B. Here's my arc with a radius of 3 centimeters, and you'll notice that it doesn't get to side B. And spoiler alert, that's going to mean that you don't have any triangles. But let's check to see what happens when you try to calculate it, because you're not always going to have a diagram to work from. All right, sine of A over side A is equal to sine of C over side C. Filling in the values I have, that means sine of 30 divided by 3 equals the sine of C divided by 10. Okay, that means that the sine of C is equal to 10 sine of 30 degrees divided by 3. Therefore, the sine of C is equal to about 1.667. That should be your first clue. If I think about the unit circle, where is the trig ratio for sine of C? 1.667. It doesn't exist, right? And if I try to put it in my calculator, if I put in arcsine of 1.667, you're going to get nothing but a big fat error. So in this situation, There are no possible triangles. Okay, so here I have my final situation. I again have side C as 10 centimeters. This time side A is 12 centimeters, and angle A is 30 degrees. And I don't know the length of side B, and if I draw an arc around point B with a radius of 12 centimeters, you can see that it intersects in two places. Okay, so let's see what happens this time. I'm going to use sine of A over side A equals sine of C over side C. And filling in my values, I know that sine of A is 30. And side A is 12 centimeters. And that's going to equal the sine of C over 10. Lost my mind for a minute. Okay, simplifying that. Sine of C is equal to 10 sine of 30 degrees divided by 12 centimeters, which is about 0.4167. By the way, if you put that in your calculator, I forgot to mention earlier that you should put parentheses around your numerator or you're not going to get the correct answer. Again, your calculator is kind of stupid, and it needs to be told exactly what to do. That means that sine of C is equal to 0.4167 roughly. Don't round that. Hang on to that and use that last answer you got. That means that angle C is arcsine of 0.4164 or 7. Use the answer you got, don't round it, or you'll get the wrong answer because trig ratios are really, really susceptible to rounding. So you should get that C. Stop. Apparently there is a bird walking across my lawn, so my dog thinks it needs to bark. Easy boy. Okay, so C is equal to 24.62 degrees. Okay, drawing that on my unit circle, I'm going to draw an angle of 24.62 degrees, roughly 24.62. You remember that sine is the y value here, positive in quadrant 1. In order to find the other place I could possibly have a positive y value with the same ratio, I need the reference angle. I'm looking for this angle right here. So again, I have to subtract 24.62 from 180. Hopefully the dog doesn't start barking again. And I get 155.38 degrees. My other possible angle. It looks like my 24.62 degrees belongs up here. So this one must be 155.38. So I take 155.38 degrees and I add it to 30 degrees. I get 185.38 degrees. Wait a minute, there's a problem here. Angle A, angle B, and angle C in a triangle can only add up to 180. Here I have 185 degrees, that's more than 180. So that means that this wouldn't be a valid triangle. So in this case, even though I could find two possible angles, only the 24.62 degrees works. So I only have one possible triangle. Here's one for you to try. Pause the video and work this out. See how many triangles you can find, and when you're ready, restart the video. All right, here you should have gotten two possible triangles. Angle C is either 41.6 degrees or 138.4 degrees. Neither one of those values violates the laws of any of triangles. I have one more for you to try. So here's another triangle. Pause the video, see how many triangles you can get, and then when you're ready, restart the video and check your answer. All right, you should have gotten one possible triangle. You can calculate two different angles, but the second solution, 138.2 and 56 degrees, add up to more than 180, so that wouldn't work. Your solution should be one triangle where angle C is 41.8 degrees. And that's it for today.